Okay, so is just about everybody here read Great Gatsby? Okay, how about this? Raise your hand if you read The Great Gatsby. Oh yeah. So, those of you who've read it, you understand, hopefully you understand this point, why it's a great American novel. You don't have to necessarily say, hey, if I'm going to sit down and read something and read The Great Gatsby again, you don't have to love it. It doesn't have to be your favorite book. But you should understand why it's so great, all right? It's that way for me a lot in different studies. I don't necessarily love certain types of studies, but I can appreciate what makes them so amazing. Today you learn what I think is the absolute coolest part of algebra, okay? So, yeah, that's arithmetic. So, we're doing algebra today. And so I will teach you the beginning of the fundamental theorem of algebra. I'll refer to it. You'll learn it more formally later on, but in order to really understand fundamental theorem of algebra, you need to understand how to divide polynomials. So that's where we start. Today will be a lot of notes. You'll have an assignment. We got to push through this because you want time to study for a final exam at the end of the year. That's really what we're doing, okay? So we got to stay ahead of the game. So 3x plus 6 divided by x plus 2. We're going to work through a few of these. X plus 2, how many times does it go into 3x plus 6? And what you do is you ask this question. What do you multiply x by in order to get 3x? You multiply by 3. Is 3 more similar to 3x or to 6? It's a constant term like 6 is. So it goes above the 6. 3 times x is 3x, and 3 times 2 is 6. We subtract. What's 3x minus 3x? 0. What's 6 minus 6? Okay, everybody pause. It wasn't by mistake that I came up with 3x here. I knew I was going to get 3x, right? I asked the question, what do I multiply x by to get 3x? So the idea is you always make sure that this cancels. This won't always cancel. In this case, it does. We get 3 with a remainder. So it divides evenly. If you look at B, B is a little bit different. Anybody know what I put after x to the third? 0x squared. You have to insert the placeholder. Just like if during the course of a week you earned $1,043, you don't really want me to write that check for 143. You would feel like you got robbed, right? Same way, we got to make sure we have a placeholder there, okay? So, x minus 2. X times what is x to the third? X squared. That's quadratic, so it goes over the squared term. Multiply, we get x to the third minus 2x squared. I subtract. What is 0x squared minus negative 2x squared? Positive 2x squared. What do you multiply x by to get 2x squared? 2x. And I multiply. 2x times x is 2x squared. 2x times negative 2, negative 4x. I subtract. What is negative 6x minus negative 4x? What is it? Negative 2x. Notice what I'm doing each time. Negative 2x is a monomial. What I have out front is a binomial. So to create a binomial, I need to drop down another term, plus 4. X times what is negative 2x? Negative 2. Multiply that through, you get a negative 2x plus 4. Subtract, and you get 0. So, did it divide evenly? Yes, it did. I need a little bit more space for the next one. Is that what the problem is? How many times does 2x go into 3 or x to the third? What do you got to multiply 2x by to get x to the third? 1/2 x squared. Very good. Here's how we did it. I'm going to use a question mark because we've got a lot of x's. The question was 2x times what is equal to x to the third? So to solve what that question mark is, you divide both sides by 2x. And you get the question mark is equal to, looks like x squared on top and a 2 on the bottom, so 1/2. Okay, so that's what's happening. Some of you might have to write it out. Some of you can do it in your brain. So we multiply it through 1/2 x squared times 2x. X to the third. That's not by mistake. That's by design. Plus 1/2 x squared minus x to the third minus x to the third. 0. 4x squared minus 1/2 x squared. 3/2. I want it as an improper fraction. 7/2. 7/2 x squared. I need a binomial, so I drop down to 0x. What do you multiply 2x by in order to get 7/2 x squared? Two x times what is equal to 7/2 x squared? Okay? So we divide both sides by 2x. So x squared divided by x gives me x. And 7/2 divided by 2 over 1 would be 7 over 4. We multiply 7/4 x times 2x is 7/2 x squared. 7 over 4x times 1, 7 over 4x. Subtract. 7/2 x squared minus 7/2 x squared. 0x minus 7/4 x. Negative 7/4 x. I need a binomial, so I drop down the negative 2. A for the day, what do you multiply 2 by to get negative 7/4? 2x times what is equal to negative 7 over 4x. Divide both sides by 2x. See that the x's cancel, you get negative 7 over 8. Whoop. Multiply negative 7/8 times 2x is going to be negative 7/4 x. Negative 7/8 times 1. Negative 7/8. Negative 7/4 x minus negative 7/4 x. 0. Negative 2 minus negative 7/8. Negative 9 over 8. So, did it divide evenly? No, it did not. So now the question is what to do with your remainder. Sometimes people write R something. That's for grade school. We're big people now. So we're going to do it the way we're supposed to do it. So let me show you. If you have, say, 13 over 4, you could write that as 3 and 1/4, right? Because your remainder is 1. It's 3 with a remainder of 1. Or 3 plus the remainder over the divisor. So in this situation, you will add the remainder, negative 9 over 8, over the divisor, 2x plus 1. Technically, that is a complex fraction. So we should simplify the complex fraction, which is just multiplied by the reciprocal. But we're not going to worry about that right now just to try to save time. And I won't be giving you examples like that in your notes or in your assignment. So Um, that's just how you want to write it. Okay. Okay, the next one's easier. Try the next one on your own. Try letter D. X to the fourth minus 4x squared plus 2 divided by x minus 1. Make sure that you are careful with your plus and minus signs. Make sure you put your placeholders in. Okay, I'm going to put the answer on the board. I'm going to work through the problem here. Okay, raise your hand if you got -1 as the remainder. Okay, so about half the class got -1 as a remainder. I want you to know that a lot of times your mistakes are with the pluses or the minuses. It's simple addition, subtraction. So that raises two questions for you, okay? Two issues. Number one. So it raises two issues. Number one, I will not have you generally do long division. Instead, we'll do synthetic division. You do need to know long division because there are times where it's used later on in mathematics. Second of all, I'm going to show you a way to check your answer. Before the problem even started, I quick looked and saw that the remainder was going to be -1. What is the solution to x minus 1? +1. Plug in +1 to the polynomial. 1 to the fourth, 1. Minus 4x squared, minus 4 plus 2. What's 1 minus 4 plus 2? -1. The remainder theorem says this. So I teach you, we're not going to write down, it's just very simple. The remainder theorem says this. If you want to know the remainder of one polynomial divided by a binomial, simply take the solution of the binomial and substitute it in. And whatever you get for a result, that would be the remainder if you were to divide it. Very plain, very simple. Look at your previous problems, folks. What was the solution here? 2. Plug it in. What's 2 to the third? 8. Minus 6 times 2 is 12 plus 4. What's 8 minus 12 plus 4? 0. And what was your remainder? 0. Look at your first one. -2 is the solution. What's 3 times -2? -6 plus 6? 0. Okay? So the remainder theorem is very important moving forward. Okay? It's a great way on your test to check your answers to see if you did it correctly. Now, let me teach you how to do something more efficient and more effective. Synthetic division. I take the solution, the binomial. I put it out front. I put a 1 right out there, okay? Then I take the coefficients and I write them down. 1, -4, 2, and 1. I draw my line. I put my box for the other remainder. So I have a box reserved up here for my solution. I have a box reserved down here for my remainder. It's just to help me stay organized. Here's what I do. I drop down my first term. I drop down the 1. And then I multiply and add. What's 1 times 1? 1. What's -4 plus 1? 1 times -3. 2 plus -3. 1 times -1. 1 plus -1. So it divides evenly because there's no remainder. What do these mean? That's my constant. That's my linear term. That's my x squared term. These are the coefficients. 1x squared minus 3x minus 1. That's the answer. Synthetic division is extremely useful, and it's very quick. Is there a question on what I just did? We try another one. What's the solution to this? Negative 2 goes into 4, 8, 0, 4, negative 7. Spot for the remainder. What's my first step? Multiply. 8 plus negative 8. Negative 2 times 0. Add. Multiply. Add. Multiply. Add. Constant, linear, quadratic, cubic. 4x to the third. Then what? Plus 4. Piece of cake upside down. Okay, thank you. So Brianna says, I like that way better. I have had students that revolt and they will not use synthetic division, so they just want to do long division all the time. Go ahead, people, freedom of choice. I just can't understand why somebody would make that choice. What is the solution to 4x minus 1? First step, drop down the 4. What's 1/4 times 4? 1. Negative 8 plus 1. Negative 1/4 times, or 1/4 times negative 7. Uh-oh, 12 plus negative 7 fourths. I have to find common denominators. Rename 12 so it has fourths. 48 fourths. 48 fourths and negative 7 fourths make 41 fourths. 41 fourths times 1/4. 41 over 16. Got to rename 3. 48 over 3. Or 16, excuse me. (48 sixteenths) plus 41 sixteenths. That's my remainder. That's my constant. That's my x. That's my x squared. So I have 4x squared minus 7x plus 41 over 4 plus 89 over 16 all over 4x minus 1. I should, I shouldn't leave it as a complex fraction, but I'm going to just because we won't see any examples like that. Just want to show you how things work out. You try D on your own. Go. A quick run through the problem. You can see what you got. Congratulations. Did you get that right? Okay, so here's the deal. I'm not going to give you an assignment over synthetic division and long division. This is something you should have learned from last year. We just reviewed it for about 25 minutes. We are now going to apply our learning to the rational roots theorem. The rational roots theorem is, I think, probably the coolest part of algebra. And here's what we know from the fundamental theorem of algebra, okay? Let me just show you an example here, okay? Fundamental theorem of algebra says if you look at the degree of a polynomial, that's how many solutions it has, or that's the number of factors it can be written as. Now, when you look at something, you're wondering if it factors. Let me give you an example. Let's say you have 5x squared plus 7x plus 2. Does that factor? Right? So your solutions to that polynomial are negative 2/5 and negative 1 over 1, right? Watch this. What are factors of 2? We'll call those p's. What are factors of 5? We'll call those q's. Look at the numbers on top, 1 and 2. Those are my p's. Look at the numbers on the bottom. So, the fundamental theorem of algebra says the degree of the polynomial tells us how many factors it can be written as and how many solutions it has. Second of all, it also says to us that if there are rational solutions, if there are rational, meaning it can be written as a fraction, those will come from factors of the front and factors of the back. We don't have to worry about the middle. So when you look at a certain polynomial, like this one right here, you don't know how it factors. But we can make a really good guess and then begin factoring it. So we use the rational roots theorem. Let the polynomial be of this form, meaning we start with x to the nth, then x to the n minus 1, x to the n minus 2. We simply write it in descending order. A sub n is the first coefficient. A sub 0 is the last coefficient. A sub 0 or A sub n has factors of q, and A sub 0 has factors of p. If this polynomial has any roots that are rational, then they are going to be of the form plus or minus p divided by q. This is so cool because when you look at this, you have no idea how it factors. But we're going to factor this in the course of about 2 minutes, and we're honestly going to take our time. All you have to do is follow my steps as I've written out here in this nice organizer. What's the degree? So it will have 3 factors. P's are factors of the last number. What are these factors? 1, 2, 3, and 6. Q's are factors of the front coefficient. 1. My choices are plus or minus p divided by q. I take all my p's, I divide by all the q's, and I write them as plus or minus. This is nice for us because q is 1. So my choices, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now we use the remainder theorem. If it divides evenly, what should we get when we plug it in? 0. It should be a solution. What number would you like to try plugging in? 1 is a great idea. 1 to the third is 1. Minus 7 is negative 6. Minus 6 is negative 12. Didn't work. Let's try negative 1. What's negative 1 to the third? Negative 1, it will be plus 7 minus 6. It works. Negative 1 works. If negative 1 is a solution, what is the binomial that divides evenly into it? If negative 1 is a solution, the binomial that divides evenly, x plus 1. So I already know this factors to x plus 1 times something else. In order to figure out what we multiply that by, x plus 1 times what gives us that, I will simply divide these two polynomials. I don't want to do long division, so I will use synthetic division. What's the solution to this? Negative 1. I have x to the third minus 7x minus 6, so I've got 1, 0, -7, -6. Draw my line. That's my remainder. What should the remainder be if we do it correctly? 0. Drop my 1. 1 times -1. -1. Add. -1. Multiply. 1. Add. -6. Multiply. 6. Add. 0. So I figured out how it factors. It factors to x plus 1 times x squared minus x minus 6. Does x squared minus x minus 6 factor? Yeah, we got x plus 1 times what? X minus 3 times x plus 2. We said it would have 3 solutions. It would have 3 factors. The 3 solutions are -2, -1, and +3. Look at these. Are they not my P's and Q's? So, when we started out, folks, we said, you don't know how to factor that. But after 2 minutes, we factored it pretty easily. Watch how quickly we can do this, okay? Now that you've seen it, let's roll through one. Degree. 3. P's. Q's. Choices. What do you want to try plugging in first? 1 to the third is 1, plus 3 times 1 squared is 3, minus 4. What does that give you? 0. So 1 is a solution. So what's a factor going to be? X minus 1 times something. We don't know what that something is until we take our original polynomial and divide it by its known factor. So 1 goes into 1, 3, 0, -4. Multiply. How's that factor? What are my solutions? You have to list the -2 twice to show it's a double root. Do you know what that graph looks like? Look at how much ground we covered in that time. We now know how to graph these things. We know how to, factor just about anything. Nothing can stop us now in algebra. I mean, it's like, what can't we do? One more problem, number 3. What's the degree? 3, what are your P's? P's are going to be factors of the last number. Q's are going to be factors of the front number. So what are my Q's? For your choices, you take all of your P's and divide them by all of your Q's. Now you have more than one Q. Sam, hit tower so he wakes up. All right, 1 divided by 1. It's a, everybody's got their tough time of the day, and it, 7th hour is tough for Tyler. He really likes math. It's all right, buddy. All right. What? But we got to see the rational roots theorem. So let's work this last one out. Choices plus or minus 1. What's another one? 3. I'd hate to plug in. You got to take, so Tyler, you got to take each P and divide it by each Q. So 1 over 1, 1 over 2, 3 over 1, 3 over 2. See them? Now, what do you want to plug in first? No! 1's a dumb choice. 3's a dumb choice. 1/2's a dumb choice. 3/2's a dumb choice. Any positive number is a dumb choice. Why? It's all positive. Right? Does that make sense to you that you're going to have a negative in there? So let's try -1. 2 times -1 to the third will give me -2. 9 times -1 squared, positive 9. 10 times -1, -10, plus 3. -2 plus 9 minus 10 plus 3, what is it? 0. So, -1 works, so what's a factor? X plus 1. Let's divide it, folks. What should my remainder be? 0. I get 2x squared plus 7x plus 3. Does that factor? Oh, come on. Yeah, it factors. Thank you. We told you guys that any positive choices would be bad choices. They were all going to be negative. Look at what I have. -1, -1/2, and -3. Those are all one of my P's or Q's. Rational roots exist. If I would have given you that right away, some of you would say factor that by grouping. Trust me, grouping doesn't work for that problem. You have to use the rational roots theorem. And it may seem long and tedious. It is extremely efficient, and it's amazing. Here's your assignment. It looks like a lot, but it's only 13 problems. 14, 15 maybe at the most. Make sure you sketch a little graph. You're going to get some time tomorrow to work. Okay? But there you go. Yeah. You should know what each one of these graphs look like. You should be able to leave precalculus knowing how to solve any equation and being able to graph any function. Because you're the best. Go be the best.